Hey guys, so tonight we're going to go over 8.9 solving rationals. I'm not going to write this stuff up here just to try and save time. So, oops, that's that little score thing. Alright, so one thing you'll notice right away is that with solving rational equations, there are two methods listed here. One is for portions, one is method using an LCD. I strongly recommend not using method 2 just because I think method 2 lends you more to making mistakes. That said, I will show you how to do method 2 when we get to an appropriate problem, just so you're aware of the process. If you really like it, you can go ahead and do that. That's up to you. It's perfectly fine. You'll always get the same answers, okay? So let's look at number 1 here. When solving equations, the real thing we care about is getting everything out of the denominator first. Okay, so I have 7 over x minus 6 equals 4 over x. And I can't figure out what these x's are without isolating x. And to isolate x, it can't be in the denominator anymore. So first I want to talk about cross multiplication with you guys. And fun story, I taught middle school 2 years ago, and they don't want us teaching you guys cross multiplication anymore. Which, I don't really care what they think, because they're stupid. Because cross multiplication gets used all over the place. So, what I'm doing is multiplying, this should just be x. I'm multiplying both sides by x. And that's going to get rid of this x. And I also multiply both sides by x minus 6. So also multiply both sides by x minus 6. And when I do this, what happens is these x minus 6's cancel, and these x's cancel. And so now what I have is, I have this 7 times this x, so I have 7x, equals 4 times x minus 6, which becomes 4x minus 24. Okay, now this, to me, this whole thing up here just looks like a disaster, okay? So instead of thinking about how we multiply both sides of the equation by both denominators, it's shorter to just think of things as cross multiplication. And what you'll notice here is if I write things like this, 7, actually I'm just going to erase this, okay? If I start with this, and instead of doing everything I wrote, what if I just took this x right here, and I multiplied it up here? And then I took this x minus 6 down here, and I multiply it by the 4. Well, if I do x times 7, I get 7x. And if I do x minus 6 times 4, I get 4x minus 24. So it turns out that taking things diagonally from each other and multiplying them is the same thing as multiplying both sides of the equation by both denominators, okay? It's just a shorter, easier way to think of things. When you multiply both sides of the equation by both denominators, it's really easy to lose track of all the stuff that was canceling. Like by the time I was done writing everything I wrote just a minute ago when I did the multiplication, it just looked like a disaster. And this is very simple, right? You can visualize 7 times x diagonally and 4 times x minus 6 diagonally. So I'm just going to be talking about cross multiplication from now on. Okay, I'm not going to talk about multiplying both sides by both denominators. That's the same thing as cross multiplication. That's why cross multiplication works. And one thing I notice, of course, is that over time, people use cross multiplication in situations where it isn't appropriate. Like addition, you have to have, notice in our problem, we have this equals sign right here. Cross multiplication only works across an equal sign, okay? If we have a plus sign here, you can't do this. That doesn't make any sense. It's just a thing for equals. So it's only for solving equations. And it's only when you have two fractions set equal to each other. Nothing else works. Don't do it. So now we have 7x minus 4x, or equals 4x minus 24. We subtract 4x on both sides. And now what I have is 3x equals negative 24. That's a 4. And I divide both sides by 3. And my answer is x equals negative 8. Now, notice up here it says, hold on, let me use my highlighter tool. I don't know, is it going to cover it? Oh, it's too thin. Let's make it thicker. It says check all, that's pretty cool. Check all solutions. Okay? You actually have to do this because if you recall from some of our previous work with rational expressions and solving equations containing rationals, we sometimes had something called extraneous solutions, which were solutions we got that didn't actually work out. Well, guess what? They're back. Okay? So you have to check. Except if there's no squareds or anything, the only thing you have to check is this. You have to make sure that you're not dividing by 0. What do I mean by that? Like, how are we dividing by 0, right? Well, let's I'm gonna erase this up here so I can write on it again. That's kind of nice, isn't it? Well, there are 2 x values that would result in us dividing by 0, right? If we, oops. Okay. If x was 0, we would end up dividing by 0. So that means that x cannot be 0. And if x was 6 over here, that would result in us dividing by 0, right? Because 6 minus 6 is 0, and that'd be 7 divided by 0. So x cannot be 0, and x cannot be 6. You don't have to write this out, okay? This is not part of your answer. It's something to keep in mind when looking at the answer you got. So we got x equals negative 8. Is that okay? Yeah, it's not 0 or 6, okay? So all you have to do is whenever you get x equals blah, you have to make sure that x equals blah doesn't conflict with your denominators and doesn't result in you dividing by 0. So it's not a whole lot of work. You don't have to, you should do the substitutions, right? You should be a good math student and put negative 8 in here and make sure everything's good. But it's not the kind of thing where you're going to get, you're not going to be misled on what the answer is, okay? So moving on to number 3. Right, so number 3, again, I'm going to cross multiply. So I'm going to take this r and multiply it over here. And I'll take this r minus 1. Wow, did I get thicker? Yeah, and multiply it up here. So now what I have is r times r is r squared. So I have r squared equals, and 4 times r minus 1 is 4r minus 4. Now I want to solve this for 0. So to do that, again, don't subtract the r squared. You don't want a leading negative, okay? Instead, subtract the 4r on both sides and add the 4. Okay, so this all cancels. And now what I have is r squared minus 4r plus 4 equals 0. And this factors into r minus 2, r minus 2 equals 0. So what's r? R is 2. Don't write it twice. It's just 2. Okay? And what can't r be? R can't be 0 from this, right? This, we can't divide by 0, so r can't be 0 here. And then what would make this 0? It'd be if r was equal to 1, so r cannot be 1. Well, this is not 1 and this is not 0, so this is okay. That's all. That's the only check you have to do for extraneous solutions. Okay? Sad news, guys. This section we're doing for this week is the last section of interesting math we're going to do, at least in my opinion. We've had a really fun-filled year of doing exciting math stuff. And after we're done with this, we're going to do trigonometry for the rest of the year. So I personally don't find trigonometry very interesting, but maybe some of you will like it. If you don't like it, well, if you're someone who's taking trigonometry next year, you know what you're going to be doing all year long. So you might want to think about what you're doing there. You can always switch to statistics. Probability and statistics is a very good use of your time. So y times y plus 5 is going to give me y squared plus 5y. And it's going to be equal to 3 times y plus 8 is 3y plus 24. Now I want to set this equal to 0 so I can do some factoring. So I'll do minus 3y minus 24 minus 3y minus 24. And now my equation is y squared plus 2y minus 24. And that's equal to 0. So this factors into y plus 6, y minus 4 equals 0. And so that means y is equal to 4 and negative 6. And are both of those values okay? Well, all you have to do is, we're dividing by 3 here, so that doesn't affect anything. But y plus 5, if I'm dividing by y plus 5, what can't y be? Y can't be negative 5. And that doesn't interfere with anything we're doing over here. We don't have negative 5 as an answer, so we're still A-okay. So thus far, I think these problems are pretty easy, and I hope that you all agree with me. These are pretty easy problems. We're not doing anything too difficult yet. It's a great way to spend your day tomorrow. Just enjoying some casual equations. All right, so now 7, things are going to get a little messier, but it's still not too bad, okay? And really, all you have to do is do a little manipulation first, okay? So first, one way to do this is to get rid of all the denominators by multiplying everything by each other's denominators. Okay, that is that's method 2 I'm talking about. Okay, so I'm going to show you method 2 real quick, and you're going to agree with me that it's gross, and then we're all going to do method 1 for the rest of the time. Okay, and we'll never speak of method 2 again, except for there'll be like one of you who's like, oh, but I really like that way. I'm like, all right, fine, whatever. So let's get rid of all these fractions. So here are all the fractions. I know that if I multiply everything by 6, I'll get rid of the 3 and the 6. So I'm going to multiply everything by 6. And I also need to get rid of the n. So I'm going to multiply everything by n also. So I'm going to make this, I'll just write like the n here, 6n. And, I could have done that better. So let's get rid of some of these for more space. 6n, 6n. And so now what happens? What's my new equation? Okay, so I did 4/3 times 6n. Well, it's 6 times 4 is 24. Divided by 3 is 8. So this is now 8n minus, my n's here cancel, so I just have 7 times 6, which is 42, equals 1/6 times 6n, the 6's cancel, so I just have n. Now, I am going to subtract the n on both sides. Actually, it makes more sense to subtract the 8n. Here, I'll subtract the 8n on both sides. These cancel. And now my new equation is negative 42 equals negative 7n. And I divide both sides by -7. And I get n equals 6. Okay, and is that okay? Yes, the only thing that n can't be is 0 right here. Everything else is fine. So that's one way to do things. And, you know, in this problem, it wasn't too bad. And it wasn't too bad because we had denominators that were constants, okay? So, like, multiplying everything by 6n isn't too bad. But if you look at, for example, number 10 down here, do you really want to multiply everything by w minus 1 and 9? Or, that's not even a really good example. That's not too bad. But, like, if you look at 12 is a really good example. Do you really want to multiply everything by both of these denominators? I personally do not. Okay, that seems just gross. So sometimes it's not too bad of an approach, but it's not the one that occurs to me naturally. Okay, so the other way to do things is to give these common denominators so we can combine these fractions, and then we are going to cross multiply. So, whoops. So to give these common denominators, this needs an n and this needs a 3. So I'll multiply this by 3 over 3. And I'll multiply this by n over n. So now what's my equation? 4n over 3n minus 7 times 3 is 21, so I have 21 over 3n equals 1, 6. Now we subtract these, or rather, if it helps you, we can just get rid of one of the 3n's and turn this into one fraction, right? When we subtract them, that's what it looks like. So now I'm going to cross multiply. I take my 3n and multiply it up here, and I take my 6 and multiply it up here. And so 6 times 4n is 24n, minus 21 times 6 is 126, equals 3n, and I subtract the 24n from both sides. So now I have negative 126 equals negative 21. And if you do the math on that, because we're going to do 126, oh wait, where'd my n go? Yeah, there's the n. 126 divided by 21, I get 6. Okay, so when I divide both sides by this negative 21, I get n equals 6. Okay, so in this problem, maybe this method was a little simpler, the lowest common denominator method, but in most situations, I think the cross multiplication method's better. I haven't misled you guys yet. Remember when I told you to take the coronavirus seriously? Well, here we are now. In fact, I would have talked to you guys about it earlier, but I didn't want to sound like a crazy nut job talking about it. Okay. So, I already give off enough of that, right? Wait, so this one right here, first I think what we want to do is we want to combine these, and I think we also want to factor this p squared minus 4. So let's do, my next step, I'm going to factor out this denominator right here, and I'm going to multiply this by p minus 2, or p minus 2. That's a p, over p minus 2. Okay, and let's see what we got now. So I have p over p p minus 2 plus, I distribute the 2. 2 times p minus 2 is 2p minus 4 over p minus 2. And that's equal to 8 over p plus 2 p minus 2. Okay? If I combine these, p plus 2p minus 4 is now going to be 3p minus 4 over p minus 2 equals 8 over p plus 2 p minus 2. Now, something interesting about this situation is this. When you cross multiply these, you don't want to cross multiply everything. Why? Well, what if I first just multiply everything by p minus 2? Well, what happens? P minus 2 and p minus 2 cancel. P minus 2, p minus 2 cancel. So it turns out these p minus 2s actually don't factor into our answer for this question at all, because both sides of the equation are being divided by p minus 2. So when we multiply everything by p minus 2, it cancels. Okay? So we don't have to worry about cross multiplying those. But I do want to take, now this is over 1 if I do all this canceling, and I just want to take the p plus 2 and multiply it up here. So if I do that, if I have 3p minus 4 times p plus 2, equals 8. Well, now I get to multiply these through. I'll have to subtract the 8, then I'll have to refactor it. So that sucks. 3p times p is 3p squared. 3p times 2 is 6p. And negative 4 times p is negative 4p. Negative 4 times 2 is negative 8. And then this, I want to cut down the writing, so I'm also doing a minus 8 here. So this is now negative 8 minus 8, which is negative 16. Okay? Let's just cut a little bit of that work. Oh. Equals 0. So I have 3p squared plus 2p minus 16 equals 0. And how does that factor? Let's see. Negative 16. Need to multiply to negative 16 and add to positive 2. Oh, I'm tired. Let's see. 3p squared plus 2p minus 16. Let's just symbol lab this. 2. Was it minus 2p? Oh, hold on. Plus 2p. Boom, let's do it. That's a factor. Look at that, wasn't that nice? So our answers are p equals 2 and p equals negative 8/3. P equals 2 and negative 8/3. I could have gone through and done this factoring by grouping, but I don't want to take the time to do it. So, we've done enough factoring by grouping this quarter and last quarter. So, we have an extraneous solution here, right? If you look at the original problem, what can I divide by? P minus 2. If P is 2, that's not okay, because 2 minus 2 is 0, so I'm doing P divided by 0. So this answer right here, this P equals 2, this is extraneous. And so my only answer is actually, and you could, on a test, on a written test, you guys know, I'd be happy with this. But on your eCampus test, it might just say P equals negative 8/3 as the answer. So just make sure you don't include don't click the option that has P equals 2. Okay? Right, so on number 11 right here, we need to do the whole common denominator thing. Actually, you know what? In this one, I think it's best to do the lowest common denominator. Instead of trying to get these common denominators and mess with that, let's just multiply everything by x plus 3. Because if you multiply everything by x plus 3, what happens? Okay, so I'm gonna bracket this whole problem. Okay, we're multiplying everything by x plus 3. And if I do that, what happens? This cancels, and this gets multiplied by x plus 3. That's not too bad, is it? So I think that's a better approach on this problem. X plus 6 equals 2 times x plus 3 is 2x plus 6. And what's left here, I have minus 5x. And we have to distribute this negative, so it's minus 5x minus 12. Okay? Now let's combine like terms. I have x plus 6 equals 2x minus 5x is negative 3x. And 6 minus 12 is negative 6. So now I'll solve this for 0 by add 3x minus 6. And now what I have is 4x equals negative 12. And I'll divide this by 4. That was a great 4, wasn't it? And I get x equals negative 3. Okay, so there's my answer right there. Now, is that okay? No. Right? The one thing I can't have. This is x plus 3. I can't divide by what? 0. So if I have x equals negative 3, that's not okay. So I have to cross this out. So what is that? What's my answer then? This is a no solution problem. Okay. So we haven't made the test all the way yet, but you can expect, I think, that there may be problems that have no solution as an option or as the final answer. So make sure you understand the checking for extraneous solutions, and then you should be all set. All right. So have a good one, guys. Hope you're all doing well. You're in my thoughts quite often.